So first of all, good afternoon, everybody. My name is Massimo Candela. I'm a senior software engineer at NTT. What I do there is mostly I work on the automation and monitoring of our network, and the presentation of today is also about monitoring. In particular, I will show you how BGP monitoring can help ease your RPKI deployment. So I'm sure that some of you already heard of this tool called BGPalerter. This is what we will use for the BGP monitoring. This is an open source tool released under BSD3 license. It's available in this GitHub repository here. And we developed it because we needed at least to have hijacks detection and visibility loss and something easy to integrate with our system. And after we added a lot of other features that you can also benefit. And it works in real time. You will get notified if something happens in a matter of seconds, and it's one of our main goals was to make it extremely easy to use. So it does include auto configuration, and it also you don't need to collect any data. So essentially, it's something that you download and run. And we will see also why that was one of our goals. So the motivation for creating it, I believe it's important to mention them, is because I personally believe, but also all my colleagues, that monitoring BGP is a fundamental activity if you operate on the public internet. And when we talk about BGP monitoring, there is always this thing that comes is like, oh, we are talking about hijack detection, which I personally don't like. BGP monitoring is not only about hijack detection. Hijack detection is a small part of it. A lot of issues today are essentially error, typos, misconfiguration of all kinds, and visibility issues and things like this. So you don't want only to monitor what other players, what other autonomous systems are doing with your prefixes, so if they are hijacking them, but you also want to monitor your autonomous system and have your autonomous system under control and be able to timely identify if you are announcing something that you were not supposed to because maybe it's a typo, or if you just deployed a network configuration and you're losing visibility. And the reasons for releasing it open source is because I believe and we believe that internet is composed of 1,000 network players, and essentially they have different level of automation expertise of softwares involved. So having software that they are easy to access and free and also easy to use will increase overall the amount of monitoring that is done, and also improve the stability of the global internet, so everybody will benefit from it. So what you can monitor for with BGPalerter. This is just a summary. You can monitor for if your prefixes, you can get notified if your prefixes start losing visibility, if any of your prefixes is hijacked, if you start announcing RPKI invalids or prefixes that they are not covered at all by ROAS. And you can also get notified if your autonomous system starts announcing something that was not visible before, and there was like a new prefix, and this it can be a typo or it can be a normal thing. And also you can specify specific matching rules on the IS path, like for example regular expressions, and get notified every time there is like a path matching such expression. So for example, you can detect, I don't know, scrubbing centers and things like this. So this is the what you would see from we have it as a Slack channel. We use it on a Slack channel. This is just an example. These are fake messages, but this is just to give you an idea. And you can integrate BGPalerter with a lot of things, not only, of course, with Slack. We will see this later. So now, when I usually do this presentation on face-to-face conference, I usually ask if you have your laptop with you, you can just follow a few steps and you will be able to monitor your autonomous system. But I know that you have some sort of device in front in this case, so it would be don't have to check. It would be easy for you. So there would be basically 2 steps. If you follow them, you will be monitoring your autonomous system, and from that we will proceed on the RPKI monitoring. So the first thing is you go on the GitHub repository. If you downloaded the PDF, which are in the agenda of the NLNOG website, you can click on this URL here. If you didn't, you just go on Google or whatever search engine you like and type BGP Alerter NTT, and the first result is going to be this repo. So you land in this page and you go in this column here on the right where it says releases, and the latest release is 1.26.0. So you reach when you click there, you reach this page which says all the changes and whatever, but the part that we are really interested is in this lower part here where you have the binaries. So we compile the binaries for Linux, macOS, and Windows. So what we will do in this quick tutorial is to just download that and run it essentially there. But you can do other things. You can, for example, clone the repository and run the source code. So just run the source code natively, or you can clone the repository and after compile it, so create a binary yourself. Or if you like Docker, on Docker Hub, there is also BGP Alerter, and there is also documentation in the Git repo on how to use it in Docker. So now we will use the binary. So I essentially have a script that I usually use to install or update BGP Alerter, which is this one, which is super easy. I use this URL provided by GitHub that instead of providing the version, I use latest, and the latest points always to the stable one, so not the pre-releases. So you do wget, you download it, you make executable, you run it, that's all. You're ready, the setup is essentially done. So the first time you run it, BGP Alerter will say, okay, I don't find any configuration yet, so what should I monitor? So it's gonna ask you 4 questions. The first of which is, would you like to proceed with the auto configuration? So you say yes, and you go to the second question that says, which autonomous system you want to monitor. You can also provide more than one autonomous system, comma separated. And you can also, we will see later briefly, you can create user groups. So they basically, you can just monitor all the autonomous system or the prefixes that you want, and basically send the alerts to different user groups if you decide. The other question is, would you like to, so if there are any other, essentially other autonomous systems that are announcing part of your address space, if that is true, you answer to this question yes. If you don't know, answer yes, in case BGP Alerter will compute it anyway, and you can revise it. And the last question is asking you if you want to be notified if your autonomous system starts announcing a new prefix that was not visible before. And I would always answer yes to this question, because as I said, this could be identification of you did a typo or some error, or if you are really announcing a new prefix, which is normal, the notification will let you know that your BGP Alerter configuration is not anymore up to date with the reality of your network, so you may want to update it. So basically, there is no real reason to say no to this question. BGP Alerter will start crunching some stuff, detecting all your prefixes and whatever, creating all the configuration, which is basically in 2 files. One is config.yaml, the other is prefixes.yaml, which they have the configuration and the prefixes to monitor. And you will see this message that says monitoring blah, blah, blah. When you see that, it means that BGP Alerter is already up and running, monitoring your resources. It means that it's getting data, it's processing such data. So BGP Alerter doesn't require, in particular, RIPE-RIS, which is also an amazing project. So they are, and the monitoring is done in the application itself. So there is no NTT server involved in the monitoring whatsoever. So you download the application and you get the data from RIPE, and the process is done on where you install the application. So if you kill this process now and you run it again, it will just say monitoring blah, 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 because the configuration is already saved. So the first time only it's gonna ask you questions. If you get a warning about like some of your prefixes are not covered by ROAS, that is okay, it will work anyway. but you may want to review that by hand, the prefixes.yaml, because essentially what BGP Alerter does is goes online, checks whatever your autonomous system is announcing, cross-validates that set of prefixes with ROAS, and if this second step is not possible because you don't have ROAS, basically he's going to enforce whatever you are announcing when you run the auto configuration. So if in that moment you are announcing something that you were not supposed to announce, you basically are enforcing that status in the monitoring. So in that case, if you're not sure if your network configuration in that moment is correct, you may want to review it by hand. It's also a good way to have a summary. So now the question, since it's monitoring, where do you get the alerts? By default, you go in this directory logs and you find file with reports, blah, 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 with a date, and you will find a sort of report like these prefixes, as jack, these prefixes, lost visibility from X peers, and blah, blah, blah. But this is, I would say, suboptimal. You may want to actually send these alerts to a more real-time approach, something like email, Slack, have a dashboard for it like Alerta, Kafka, Sysglo, WebEx, Mattermost, Telegram, Pushover, or any HTTP endpoint. So you can basically create your own API and BGP Alerter will send post requests. These are all supported by default. And also, we really care about making the process really not noisy, and the alerts are automatically bundled and throttled. I will come back to this point later. As I said, you can define groups that they get specific alerts to specific groups or specific type of alert to specific platform, like some on Slack, some by email. You can decide. It's really flexible. And it's important to remember BGP Alerter doesn't only send the alerts, but also sends, stores the BGP messages, the BGP updates that trigger such alerts. So in case you want to go and do troubleshooting and understand better what happened. So this is an example of report by email. This is the one we saw on Slack. This is the Alerta dashboard, which is a dashboard that is open source, extremely easy to install. You basically install this, and after you say to BGP Alerter which host and port this dashboard is receiving data, and that's all. So now coming back to the noisy part. So BGP Alerter, the default configuration today is extremely silent, at least for my experience. So if you have a case where BGP Alerter is noisy, mostly is because of the cases that I reviewed are because at the beginning, such configuration was not optimized like it is today. You learn on the way. So what you should do is probably to update both BGP Alerter and reapply the default configuration that you can find here and maybe add the changes that you added. But in particular, check this threshold min peers and check if you set something reasonable. Check on threshold min peer says, don't send an alert if this issue is not visible from at least X peers. I would say at least 2 is a good threshold because you don't want to see small things happening between 2 autonomous systems. And also, if you have prefixes that you use for all sorts of experiments, you can exclude those. So now we go in configs.yaml that was generated automatically by BGP Alerter. So your application is already monitoring and whatever. We just see that there is this part connector where you check where the data is coming from, in this case, RIS, and there is this part of the monitors. We will focus now on the monitors. Each of them is a plug and play monitor that you can remove by commenting it out, or you can add others, you can implement yours, you can do whatever you want. And so, for example, you have hijack, new prefix, path, visibility, blah, blah, blah. And the last one is monitor RPKI. We will come back to this one in a bit. So we'll keep scrolling, and here is the section with the reports. By default, only this one is enabled to write on file. But if you go here, you can have report email and all sorts of reports. You basically remove it from the comment and you change some configuration like host port, username, password, or whatever. In case of Slack, you put like the URL of your webhook, or if you have an HTTP API, you put your HTTP endpoint. That's all. Now, a really important part is this process monitor. So when you use BGP Alerter in production, you need to monitor the BGP Alerter process. You need to basically be aware that you have to know if when BGP Alerter is silent, if it is because nothing is happening or because it's not working at all. So for example, connectivity is not working on that, the VM went down or things like this. You need to monitor the monitoring process. To do that, basically there are some options here. One is called Uptime API, which essentially creates an API that you can query periodically, and BGP Alerter will answer what's the status, or the opposite way. So provide a URL, and BGP Alerter periodically will query that URL in a sort of heartbeat fashion. I usually use the first one, so I removed it from the comment. I port by default is 8011. You can put whatever you want. And if you go on the browser and you go on localhost 8011 status, you restart the process, you will see that you have this JSON now, this API that says warning false. You can monitor that warning false. There is a summary. If warning is true, here it will tell you where the issue is. Maybe a connector is disconnected, maybe the data source is down or whatever. It's really stable usually, but you need to monitor it anyway. If you don't want to read the payload, for example, you want to configure it in Nagios, you can read the payload, or you can also just listen, read the HTTP status code. And if it's 200, it's fine. If it's different than 200, you have an issue. So now let's focus on the RPKI deployment and the support. So what we want to do is to have BGP Alerter to timely notify us if we are announcing RPKI invalids or prefixes not covered by ROAS, both at the entire SNever or for specific prefixes. And we want to have alerts like this, where we say what the issue is and also which ROAS cover such prefix. So this is particularly useful before you deploy RPKI, during RPKI deployment, and after you deploy RPKI. The reason is before you deploy RPKI, you can use this to basically test how life with RPKI will be. And we will see what that means. During RPKI deployment, you can use it to get him notified if you are announcing something invalid. And after RPKI deployment, also to get him notified, not only if you're announcing something invalid, but also to check if everything that you're announcing is covered by ROA and if your network configuration is aligned with the ROAs that you define. So we go back in this configuration here, and we go back in this monitor RPKI. And there is the, let's check two parameters. This check uncover, that is by default is set to false. It means, do you want me to notify you for prefixes that are not covered by ROA? So if you set it to false, it means no, only notify me for RPKI invalid. The other important parameter is this highlighted here. There is VRP provider, which is NTT. So what's a VRP provider? VRP provider is essentially somebody that does the RPKI validation and generates a file with a list of prefixes, autonomous system that should originate that prefix and a prefix length. So there are at the moment two providers that they, or at least two that I'm aware of, which BGP Alerter supports both, which is one is NTT, the other one is RIPE NCC. And you can put, if you want RIPE, you can put RIPE. If you want NTT, you put NTT. So this is clean, easy in a way that you download the process and it just runs and you don't have to do anything by yourself, but it's not probably the best way to go. You are using this to monitor, so you are not using this VRP file to enforce your network policies, but still you're basically monitoring with the RPK validation done by somebody else, which I said it's easy, but not the optimal solution. Because essentially you are trusting somebody else to do that. So what you should do, what you could do is to essentially generate those VRP file yourself periodically and point BGP Alerter to read that file instead of to use a provider. And what I strongly suggest is to use this RPKI client, which is open source also. It's available in these two links. It's basically available for FreeBSD and all major Linux distribution. And one of the developers is Job Snyder. And you have this, another thing that you will need is this JQ tool. I like to give instruction that they are really copy and paste, because I like to, when I do stuff, also to see those when I want to test stuff or fly. So This JQ also, you can install it with apt-get, brew is everywhere. And here is the copy and paste line. So what you do is RPKI client -J to get the JSON output, because we need that, and you set which directory you want, like test in this case. And after you do cut, you pipe it inside this JQ to do a small manipulation, and you write your test BRP JSON, which is in the format supported by BGP Alerts. Possibly in the future, I will make it polymorphic and accepting various formats by default, but for now, this is the small thing that you have to do. Anyway, it's like one line, you put it in cron tab every 15 minutes, and you are good to go. So here, you removed, instead of BRP provider, you replace it with BRP file, and you put which file it is. BGP Alerter starts a watch on that file, and every time you change it, it will reload the VRP definition. So now we said that you can use BGP Alerter to test how it would be to have RPKI in your network. So it's clear, it's easy now to see how that can be done. So let's go directly to see how that VRP file is done. So it is essentially a list of these JSON blocks. Each of them has SN prefix max length, and it's just a JSON file. That's probably also why you should generate it yourself. So you can, if you want, you can just write whatever you want in this, and you are faking RAWs in basically that way. So you are saying to BGP Alerter, use these as RAWs. And what you could do is to write here what you are planning to sign as RAW without signing it yet, and leave it running the monitoring for some time, maybe a month. So that BGP Alerter will let you know if you at some point start announcing something that contradicts such RAWs. But in particular, it's extremely useful to check if your organization is able to stick to the signed RAWs, to kind of develop a policy to coordinate. So it is a really common case that you sign the RAWs, and after you forget about it, and you start announcing something that is more specific and has a prefix length different than what you are allowing the RAWs, and so basically that is a RPKI invalid. Or that you, and that sometimes it can be done because you need it, because maybe you are under hijack or whatever, you need to do that. Or other cases are like if you start announcing something and you forget to sign the RAWs. So you leave it running for a bit, and you kind of also see how it works, and if you need to develop some coordination with your inside your organization. So that's all for my presentation. I would like to remind you that the code is open. This is the GitHub repository. You can go there, you can contribute, you can like it, you can do whatever you want there. I created recently a page that it's just 2 days ago, where essentially if you're using BGP Alerter and you would like to just say that, you just can put your company names there, just to make me happy. There is no other. And that's all. So this is the repository. And if you have questions, that is the moment. Thank you very much.
Thank you, Massimo. Really interesting. And yes, there are a few questions. We're a little bit short on time, so you might want to tell folks as well how they can reach you in case they have follow-up questions. But the first question we received is, would it be possible to offer some kind of BGP Alerter as an online service to the public?
You would be. It was actually, it would not be particularly difficult to do. I mean, for now, we didn't focus on that. We may think about it, but yeah, it definitely would be not difficult to do. But anyway, it's what I would say is extremely easy to use. So I would try first to do it like this, but it could be an option.
Okay, second question. What is the big difference between your tool and the RIPE RPKI alerts you can get from, or the RPKI alerts you can get from RIPE?
Well, first of all, this is, let's say, a tool that does all kind of monitoring at once, and you may find useful or not to have also the RPKI together. And also it is has various type of integration. So it is mostly this, and it is also, you can use it across all RIRs independently of where you sign your ROR.
Okay.
That is at least my answer.
Yeah, so we also received a suggestion as with regards to the field where you enter the autonomous system you want to monitor. Would it be possible to specify an AS macro by name?
So to specify the AS, no, for now, no, you have to specify AS numbers. There is no other option. But I mean, I didn't, maybe I didn't get it, but from the name, it's you go on Ripestad, it's easy to get which autonomous system is. Maybe I didn't get the question, sorry.
Well, I think the question is related to having the option to, indeed, via entering an AS macro, being able to enter a number of ASs in one go, right? Instead of entering them one by one.
Oh, I got it. So basically like match all Google thing. And no, there is no such option. Honestly, I tried in the past for another project to do that. It's if there are some complications on that, because sometimes some operators, they associate names of IS they used to peer like with somebody, and it can be not correct, but it could be a feature request. We could add it. Okay.
Last question for now. Have you published this tool in an academic journal or conference? Because the asker of the question is curious about which algorithm and techniques has been used.
So no, they are not published because I don't think at the moment there is, maybe it could be done, but I don't think at the moment there is so much, let's say, science behind it. The code is open source. There are also other solutions available that they mostly focus on hijack. So the easy answer is not published, but if somebody wants, the algorithms involved are not particularly difficult, and they are open.
Okay, thank you. And with that, thank you very much, Massimo, for this really interesting presentation.